This is the first part of two videos looking at some questions involving circle theorems. We cover a variety of different questions, and I go through and explain the type of things to look for when you're looking at a question for the first time, and the clues in that question which will help you hopefully try and find your way and navigate your way through to the correct solution. With every circle theorem question, you need to take a moment just to study the diagram and the information that you are given. It will give you hints in terms of what your answer or what your method should be. So if we look at it here, we have a point B, we have a circle, we have tangents going from B to the circle, we have the center, and we have the radiuses. So straight away, you've got tangent, radius, center. So you know, without any thinking, that these angles here will be 90 degrees because tangents are at 90 degrees to a radius. So that's the first thing you would write down. Now, here's the thing that many people don't spot. What shape have we got here? What is ODBC? That is a quadrilateral. It's not a cyclic quadrilateral because it goes outside of the circle, but it's still a quadrilateral. And what do we know about that quadrilateral? Well, I know three angles. I know 66, 90, and 90, and all quadrilaterals add up to 360. So therefore, I know what this angle is here. So this is angle DOC, and DOC equals 360, subtract the three angles I know, 90 plus 66, which equals 114 degrees. And that's because angles in a quadrilateral, don't put cyclic quadrilateral, add to 360 degrees. So I know this angle here is 114. Now I look again and go, okay, if I know what this angle is, I know what this angle is because I have a complete turn. So we want angle DOC, but this is the reflex angle. The one before was the obtuse angle. DOC reflex is equal to 360 subtract 114, which equals 246 degrees, because angles in a complete turn add to 360 degrees. So this angle around here is 246. And then we get the bit where most students just don't spot it. We're trying to find y. This shape here is a quadrilateral, but it's not a cyclic quadrilateral. I can't use that. But this angle here relates to this angle 246. This angle at the center is twice this angle. It's the rule where, if you think about it, we have this little shape here. We have a center, and we have what I refer to as the Star Trek theorem, because this is a symbol that they wear on their vests. This angle here will be twice at this angle here. But all we've got is we've just stretched it out. If you think about stretching it out a little bit, so I've got this angle here, this angle here, this one is twice this one. And if I keep going, then what I've got here is this angle here is still twice this angle here. So I know that angle DAC is equal to half of angle DOC reflex, which is a half times 246, which is 123 degrees, because the angle at the center is double the angle at the circumference. So just reviewing this question very quickly, I started by just not even thinking what was the question asking me for, but what do I immediately know? Tangent gives me 90 degrees. A quadrilateral means I can work out the other angle. Then I have angles at a point, so I know this one. And then I start looking circle theorem. Okay, this angle here is twice this angle here. Now, on first inspection, this question might look horrible because it's got algebra. You've got algebraic expressions. We don't know the size of any of the angles. Two of them are written using algebra, but it doesn't matter. The circle theorems don't change. It just means we're going to have a different approach to finding our solution here. Now, this actually uses something that we used in the previous question in terms of the Star Trek symbol. The angle at the center here is twice the angle here. So if I can work out this one here, it's going to be equal to double this. If I can form an expression then involving z, then I should be able to solve the expression and work out the value of z. So the first thing I want to work out is this angle here. So what have I got there? This angle here, well, that's going to be 360 minus the other angle. So it's z plus 178. And if I work that through, that's going to give me 182 minus z. And the reason is that angles at a complete turn add to 360 degrees. So that's my reason, that's my calculation. So I know that this is 182 minus z. Now, as I said, this angle here is going to be twice this angle here. So I can form an equation for that. I can say that 182 minus z is equal to twice the angle at the circumference, which is 3z. So studying this, I have an equation, one equation, and there is only one unknown, which is the letter z. One equation, one unknown. I can solve this. So let's tidy it up and see what I get. So I got 182 minus z equals 2 times 3z is simply 6z. Add z to both sides, so 182 is equal to 7z. And then dividing through by 7, z is going to be 182 over 7, which works out very nicely to 26 degrees. So if you get a question involving algebra, just try and form an equation. Try and form an equation, an expression here, especially if you're then trying to find the actual value for the variable there, and you should be able to solve it and get a nice answer.